Okay, so this video is going to be looking at the first part of forming and solving equations, and then I'll continue in this playlist. The first thing we need to look at is some definitions of what a term, an expression, and an equation is. So a term might be a single constant, so just a number like 10, -5, or a half. It might be a combination of a number along with one or more letters, so it could be 5a, 6ab, half ac. It could be, there might even be powers involved as well. So for example, 2x squared, -3/2 b to the power 3. Or you could even have decimals as well, 0.2 f to the power 6. All of these are individually terms. An expression is where you have more than one term put together. So for example, a half plus 2a, or something simple like 3a plus 2b. You can have 4a minus 3ab. Any combination of terms will make an expression. And you can have any number of terms as well. So you can have something like 3a plus 4b, take away 3z, and it could just go on. And that would just, all of these are examples of expressions. Now, an equation is just where you have an equal sign in between two expressions, and it shows that these two things are equal. So for example, 3a plus 4 is equal to 10 plus 2a, for example. You may even have a constant on one side as well. So you can obviously rearrange equations, and you've seen equations already. So another basic simple example, 2a plus 8 equals 7, or 4a plus 7/2 is equal to 17, for example. All of those are different equations that consists of individual terms, but you wouldn't necessarily talk about expressions when you're talking about equations. So knowing this, spend a minute sorting all of these into categories. Either they are terms, either they are expressions, or they are equations. And then I'm going to show you the answers. So pause the video to have a go. Okay, so I'm going to show you the answers for this now. So this is a term, term, term. These are two terms together, so it's an expression. This is a term, term, expression, expression, expression. This is an equation, equation. That's an expression. This is an equation, term, term, expression, equation. So these have now been sorted into categories, and we're good. This is important, this language, when we're looking at forming and solving equations. Okay, so first example of a question where you have to form and solve an equation. Mr. V put some number of counters in each tub. We don't know how many there are. We're going to write an expression to show this. So we don't know how many there are, so we can just pick any letter. I'm going to stick with X for now. So each tub has X counters in it, and because there's the same number in each tub, so that's why it's the same letter. Now, if you want to know the total, it's going to be X plus X plus X. So that's your expression. And yes, it does simplify to 3x, which is a term. If he adds 6 more counters, there will be 51 in total, 51 counters overall. Write an equation to show this. So we know we've already got 3x counters. He's then added 6, and that adds up to 51. Now this, what you've just done here, is you've formed an equation from this worded information. And the last step, you can probably guess what that is how many counters were there originally. So basically we're working out what x is. To work this out, we have to solve this equation. So we're going to solve this using the skills that we already have. We're going to take away 6 from both sides. So that will give you 3x, and then that's a 0 pair. And then 51 take away 6. So that's going to be 45. And then you're going to divide by 3. So x is equal to 45 over 3. And that gives you 15. So x is originally 15. And we can check that by just substituting it into here and say 15 times 3 plus the 6 more counters that we have gives you 51. Let's do another example here. So Mr. V put some counters in the first tub and twice as many in the second tub. Write an expression for this. So we're just, again, we'll stick with, we'll change a letter to another one. We just call it P, just for giggles. So if that tub has P counters, this one has twice as many, so it's going to be 2P. We're going to add them up because we want an expression for the total. And yes, this does simplify to give you a single term, which is 3P. If he had 2 more counters to each tub, so in other words, we're adding 2 here and we're adding 2 here. So overall, we've added 4. Write an equation to show this. Well, we started with 3P and then we've added 4. And then it says there are now 40. So that's going to equal 40. And that's your new equation. So you've now formed an equation. And then the last step is to solve this equation. So we're going to solve this by taking away 4 from both sides. So 3P, that's a 0 pair. 40 take away 4 is 36. And then we're going to divide by 3, P is equal to 36 over 3, which is 12. So originally P was 12. And so there were 12 in here and 24 in there. So how many counters did you put in each tub? So we do need to write 12 and 24 as our answer. Okay, another example of forming and solving an equation. So Liwat put some counters in the first tub and half as many in the second tub. So we can pick whichever letter we want. Let's go with Y. So this is going to be Y and this is going to be half Y. We could write this in another way. We could say that this is 2y and this is y, because technically one tub has half as many as the other one. So both of these would be correct. And it says there are 42 counters in total now. Write an equation to show this. So we can say, I need to get over that one. I'm not sure about that. Let's try again. Okay. So looking at another example, Liwat put some counters in the first tub and half as many in the second tub. Write an expression to show this. So there's y counters here and then half y counters in the next tub. There are 42 counters in total now. Write an equation to show this. So we know that when we add these up, that would be the expression, but to make an equation it's going to equal 42. And then what we're going to do here, obviously we're going to work out how many were originally in the tub. So here we can say 1.5 or 1.5 y is equal to 42. And then we can divide. Now it might be better to write this as a fraction. So 1.5 is just 3 over 2. So to work out what y is, we're going to times 42 by 2 and then divide it by 3, and that gives us 28. So y is 28, and then half y will be half of that, which is 14. Now you may approach this in another way to avoid the fractions. Instead of doing y and half y, you could say the first tub has got, you can just say it's got 2y counters, and the second tub will have half of that, which is 1y. Our expression would be 2y plus 1y, which becomes 3y, which is a term, and that's equal to 42. If we then solve this by dividing by 3, we get y is equal to 42 divided by 3, which is 14. So that tells you that this is 14 and this is 28. So you still get the same answer as the original question. It just avoids us having to deal with fractions. Okay, next example. Tiara puts the same number of counters in each tub. Write an expression to show this. Well, in this case, we're just going to call this x and x. So the expression would be x plus x, which is just 2x. She doubles the number of counters in both tubs. So now we're going to put this in brackets and put a 2 on the outside. Or we can just say this is 2x plus 2x. So the expression would be 2x plus 2x. We know that's just going to simplify to 4x. Now there are 64 counters in total. Write an equation to show this. Well, that's going to mean 4x equals 64. And then solve the equation. So we're going to divide by 4, divide by 4. So x is 32 divided by 2 is going to be 16. And that's it. Okay. Let's look at a more practical example of a question. A box contains 100 grams of flour. Some of the flour is shared equally between the 5 green cups. There is 20 grams of flour left. So there was 100, there's 20 grams of flour left. How much flour is in each cup? Now, I know you can probably do this in your head straight away, but let's try to do this in the way it's intended, which means forming an expression and an equation and then solving that. So we know we started with 100 grams. If it's shared equally between 5 cups, what we know is there's some value which is the same, some weight of flour in each cup. I'm going to call it all x. So when you add these all up, along with the 20, it should equal 100 because you started with 100 grams. So this all adds up to 5x. So 5x plus 20 must equal 100. So we're going to work this out and just work out what x is. So this question is very easy to do in your head. However, when the numbers get a lot trickier, then you need to be able to know this method. So in this case, we're going to solve it to work out what x is, because that's the amount of flour in each cup. Take away 20 from both sides. So 5x equals 80. And then we're going to do 80 divided by 5. So divide by 5, divide by 5. So x is equal to 16 grams. Okay. Make sure to watch the next video, which will have more exam style questions like this one, so you can continue working on this topic. I'll see you in the next video.
I'm afraid your journey ends here, traveler. I'll be taking whatever you're carrying, after you're dead, of course. I do hope it's more than the last few had. They were most disappointing.